So before I start, I would like to thank the China Electronics Standardization Association for inviting Maxwell to this event and for giving me the opportunity to provide the keynote speech for this very important gathering. My name is Michael Everett, and I am from Maxwell Technologies, currently the world leader in capacitor technology and manufacturing. I've chosen the topic of change to start this discussion in this conference. The world needs to change in order to see a brighter future. Our planet requires it, and our society requires it. The rate of change must be extreme. The world is in a deepening energy crisis. Humans and the environment alike must see and feel the change impacts now, not later, and not in any small way. There are precious few times when a new technology can produce such broad and deep changes as the one we have here. Ultracapacitors can instigate that change, and they can do it at the rate required. In the way they operate it, the applications that they enable, the markets they serve, the impacts they have on how energy is managed, and the positive influences on the environment, the ultracapacitors participate in, implement, and drive change. I am sure that's why this conference is being held and why we're all here. The ultracapacitors will enable the big changes that the world needs. The industry as well as the energy storage markets need to act together with speed and with purpose. We need to advance the technology, drive the applications, and bring about the changes we know we need, not only to survive this crisis, but to flourish amongst it. I am proud and excited to be part of such a movement that has the ability to influence the future. This conference is about leading edge technology and its influence. When individuals recognize not only the need for change, but the solutions that are enabled by leading edge technology, the organizers and attendees of this conference recognize that need, recognize the opportunities the ultracapacitors represent, and can see a future in which this important technology plays a key role. People generally think in terms of energy or about steady state operation, but we always act in terms of power or changing conditions. When you think about it, there are really only three states for all things. Either they are changing, they have just changed, or they're getting ready to change again. This makes changing a much more critical state than static operation. Further, to be able to recognize the need for change, steady state has to be reached. That's the only time one can decide to change, when the steady state condition is recognized, and that's when the requirements for change are obvious. Whether it be slowing down, speeding up, changing direction, moving higher, moving lower, becoming hotter or colder, changing is always the natural state of things. And when the rate of change is important, and whenever is it not, the agents of change must be capable of very rapid response, very deliberate action, and able to deliver what is required. The ultracapacitor finds its utility and its ultimate value in bringing about change. And if we all agree the change is necessary and necessary now, then the ultracapacitors, by their very nature, are part of the future and play an important role in bringing about that change. I contend that it is when things are changing that the highest value is created. Without the appropriate agents for change, the continuous driving need for constant change will render a static system ineffective or even worse, damaged. Take the example of a wind turbine and blade pitch control. If the wind turbine is unable to generate rotational motion due to the blades of the turbine being maladjusted for the direction and speed of the prevailing wind, the turbine is valueless. Very expensive, but having no value. However, if the pitch of the blade is appropriately adjusted via a burst of power, suddenly the turbine starts turning and begins to perform its intended function of generating electricity. I would maintain that burst of power is the critical need, the critical change agent that brings the value to the wind turbine. We cannot tolerate that condition in such a time of dire need for our planet. We must proliferate the true agents of change, the ultracapacitors, into the energy infrastructure to bring the highest value change solutions to the critical problems we are tackling. Most industry reports and predictions show very strong growth in the energy storage industry in general, in all technologies, including batteries and other advanced energy storage technologies. One industry study shows the automotive lithium-ion battery market predicted to grow at a compound annual growth rate of about 16% between now and 2025, all predicated on achieving strong performance improvements and very big cost reduction. The ultracapacitor industry has been on a significant upswing as well. The Navigant Corporation predicts the market for ultracapacitors between 2014 and 2023 to grow approximately 20 times, a very healthy compound annual growth rate of 39%. At Maxwell, we have experienced similar growth over the past 4 or 5 years, amounting to about 35% per year. These facts bode well for the future of ultracapacitors and signify to the world that the ultracapacitors are, as we all know, an important technology. As the application space for ultracapacitors becomes better defined, the value proposition of the technology becomes more well understood, and the customer base becomes more educated and sophisticated, it is clear that ultracapacitors will enjoy continued growth in both existing and new applications. Nice. In order to make sure the growth opportunities are taken advantage of to the fullest, the manufacturers of the technology have got to keep their eye in a number of areas, including, number one, continued enhancement of the value proposition of the technology, primarily through lower cost, but also through better performance. Number two, we must regard the advancing battery technology with the appropriate respect and attention. There's a vast amount of energy and money being invested in battery technology business in an effort to achieve a one-size-fits-all solution. While it may be significantly challenging to achieve something like this, the probability is not zero, and therefore the ultracapacitor makers must pay very close attention to these developments. Thirdly, we must continue to educate customers on the benefits of ultracapacitors. While it is clear to all in this room just what ultracapacitors can do now and will do in the future, it is not fully clear to all those in the industry. More education must be achieved. And finally, we must recognize the end user needs a system solution, not a cell. And as such, it's up to the manufacturers to create partnerships and critical industry linkages and relationships, as well as concentrating on developing in-house capability for energy storage systems integration. If we address these 4 critical needs, the industry will accelerate the adoption of the technology and deployment into those applications which can have the largest impact on the world energy stage. Regarding the technology of ultracapacitors, focus must be on 2 primary areas of advancement: energy density and customer investment cost. The energy density component of the capacitor is not required to provide steady state runtime or static operation, but rather to enable the dynamic mode operation of the devices for a little longer than they are currently capable. Delivering power for longer time fulfills that need. Higher energy density in all energy storage technologies enables lower cost at the device and the system level, smaller and lighter solutions for a particular application, and longer operating runtimes. For ultracapacitors and other electrochemical energy storage devices, this energy density improvement comes in the form of higher device operating voltages, higher specific capacitance, and improved packaging technology. With these improvements will come new applications and market opportunities which will support high volume production, reduction in manufacturing costs, and advancement in system implementations, resulting in unlocking of the tremendous potential of this technology. As the technical community that's designing tomorrow's solutions to energy management challenges know about ultracapacitors, and as ultracapacitors become more widely accepted for the strengths to bring about change, then the more these devices will find their way into applications. The current largest market in the world for ultracapacitors is in the transportation sector, and the largest application in that market is the hybridization of passenger buses with energy storage. China is leading the world in the build-out of this perfect application for high power storage, and is the largest consumer of ultracapacitors. Utilized for propulsion and regenerative braking energy recapture, the ultracapacitors provide superior benefits to the application. Reduction in greenhouse gases, reduction in fuel consumption, and improved performance in acceleration are the main benefits. Bus makers in China are demonstrating to the world that this technology can be deployed with great effectiveness on an industrial scale. The future outlook for ultracapacitors in the hybrid bus market is very strong, with China leading the way. That takes me to another application, renewable energy. Another market segment that has adopted and made significant use of ultracapacitors. Ultracapacitors have been installed in wind turbines to provide power for blade pitch control. The devices have been in the field for a long time, with close to zero failure rates in service and lifetimes now exceeding 10 years. In this application, the devices are replacing battery systems and hydraulically actuated pitch control systems, which are expensive, have reliability problems, have service considerations, and show some performance concerns. Ultracapacitors have eliminated those concerns for the pitch system makers that are leading the way and leading the industry with progressive technology like the ultracapacitor. Another area of emerging applicability for ultracapacitors is in the grid space. The dynamic rate of change of demand and the highly variable nature of this requirement makes frequency regulation a perfect candidate for ultracapacitors. Thinking energy and acting power is what I would say the grid is all about. One might be tempted to think that the biggest challenge for the healthy power grid is a stable energy supply. But in reality, the biggest challenge is dealing with the transient nature of the requirements of the grid. Short-term high power requirements are a greater concern than the supply of steady energy. And as renewable energy sources increasingly penetrate the grid, the instability the grid is exposed to will likewise increase. And to mitigate the negative impacts of those instabilities, the system designers will find value in the ultracapacitors. Of course, any discussion of ultracapacitors or applications would not be complete if the automotive applications were left unmentioned. The automotive market represents perhaps the most diverse ecosystem for the deployment of ultracapacitors, and in the dynamic use model of the automobile and the drive toward electrification of the system, the need for ultracapacitors becomes increasingly obvious. From engine starting to propulsion to active suspension, electric turbocharging, board net stabilization, the applications of electrical energy in the automobile require short-term dynamic power with the highest reliability and longest lifetimes. There are a few commercial deployments of ultracapacitors in the automobile. The first one reaching industrial scale being the VSS system, commercialized by the Tier 1 automotive supplier, Continental from Germany. This slide shows the architecture of the system and the benefits of such a system. Since 2010, there are more than 1 million cars on the road using this VSS system. The performance and reliability are on par with the requirements of the highly demanding automotive market. Supporting the lead-acid battery with ultracapacitors does two things: providing superior cranking power and also providing the board net with a stabilizing voltage to make the start-stop function in the automobile seamlessly smooth and comfortable. Data is not yet available on the influence of the ultracapacitor on the lead-acid battery that is in the system, but it is believed that there should be some positive benefit. The battery should last longer than otherwise would without the support of the ultracapacitors. The world should be very interested in this data, as it represents the longest term and largest sample of automotive deployed ultracapacitors in history. And to know the benefits of the devices on the battery function and health is a very critical part of the integrated energy storage solutions in the future. The railway market is the last market I will discuss today as being perfectly suited for ultracapacitors. The high power available upon braking of a train entering a station and the benefits of providing propulsion assist from that captured energy provide undeniable benefits. Indirectly reducing the impacts of energy generation by making best use of kinetic energy, as it is in the bus application as well, and avoiding the requirements for more electrical energy generation, transmission, and distribution has obvious benefits. The ultracapacitors have the ability to efficiently capture that braking energy and deploy it with the same efficiency to either propel the cars from the station or otherwise divert it to the energy grid for frequency regulation. Ultracapacitors can be located either on board or wayside at the station, depending on the use model. The rail market is destined to be the next big worldwide market for the deployment of ultracapacitors. The benefits are known, the application is worldwide and prevalent, and the capability of the technology is presently available. As the market recognizes the benefits and the manufacturers of the technology uphold their end by reducing costs and improving implementation logistics, the application will flourish. As a final word on the applications for ultracapacitors, it should be recognized applications are generally split between power demand, dynamic changes, and steady state conditions, either just changed or preparing to change again. The ultracapacitor has the ability to change the way energy is managed in any system. Using battery-optimized batteries are less expensive than compromised batteries and more energy dense than the compromise of a battery having to handle both energy and power. Therefore, it holds more active material in a smaller volume and costs less to produce. The ultracapacitors can be ideally designed to match with the battery system and handle all the power and transient requirements of the application. Formal studies have shown that this configuration, when properly designed, prolongs the battery performance lifetime anywhere from doubling to up to 6 times the lifetime. This is a significant cost benefit as well as a service benefit to the application and the customers. I would suggest that the combination of batteries and capacitors will begin to dominate the energy storage architectures in the next 3 to 5 years and will never look back. In industrial applications where reliability and lifetime are paramount, a combination of batteries and capacitors provide the optimized solution and one in which there is no rival. Sorry. This slide does illustrate the benefits of combining batteries and capacitors together, showing an engine cranking application which exhibits lower engine cranking current carried by the battery, faster engine starting, and stabilization of the board net in the vehicle. It's the simplest example of combining batteries and capacitors together, but a perfect illustration of the hybrid energy storage system benefits. Look for this architecture to lead the future of ultracapacitors into applications which share the need for steady state energy and dynamic power delivery. Maxwell Technologies is a world leader in ultracapacitor technology and manufacturing. With our business well over $125 million annually, we're driving the industry forward along the help with many competitors worldwide. Maxwell has recently introduced an industry-leading technology specifically designed to be operational in the most physically demanding environments, the DuraBlue technology. Additionally, newly introduced 2.85 volt 3,400 farad capacitor provides industry-leading energy density in an ultracapacitor. The significance of this higher operating voltage and higher capacitance in the same package is a 25% energy density improvement, translating in a few ways to benefit the customer in lower cost, smaller packages, and lower overall system costs. And this is just step one in a long line of progressive improvements that will take ultracapacitors from the modest business it is to the large business it will be. Maxwell's product line is diverse. We're working hard to continue to expand our product offerings at the cell level as well as the system level. We have a large range of ultracapacitors varying in size from 1 farad to 3,400 farads. The large ultracapacitors are available in a variety of module configurations designed to enable system implementations and standardized applications. We're working continuously to refine these designs, improve overall performance and the cost structure of the modules and the systems, and to deliver volume with the highest quality. Maxwell's proprietary electrode is at the heart of our performance. The dry processing of the electrode requiring no solvents is continuous rather than batch, enables thick films with high durability and integrity, and is efficient and clean. Dry electrode has specific lifetime and performance advantages, enabled by the lack of solvents which have to be removed prior to use. This cleanliness means longer lifetime and higher performance over the lifetime of the device. Maxwell owes some of its success to its strong business in China, fueled by growth in power demand in both the wind and transportation markets. And our business in China has taught us many things. We manufacture in China, we sell into Chinese markets, we use China to supply some of our critical components. We are closely tied to business in China and look forward to expanding our service into the Chinese markets in the coming years. The Chinese auto market, as well as the grid-scale technology developments, are going to be key drivers of Maxwell's success in the future, as well as driving the world's overall growth in ultracapacitors. We have begun some grid-level projects in China with prominent Chinese entities and are looking forward to the commissioning of these systems to demonstrate the strengths of ultracapacitors and what they can do for these applications. China is on the path to directly impact the worldwide ultracapacitor business, both in the short and the long term. The drive and commitment of the central government to bring green technology to China and to the rest of the world, coupled with high level of activity in the energy storage space, positions China very well to participate in the revolution and drive change across the globe. In order to serve the expanding market and escalating demand for technology in China, new companies are finding ways to generate business and to gain a foothold in the Chinese energy storage and power delivery markets. Competitive pressure is high from new, strong entrants to the market. Some from China, some from other countries. This competitive pressure is necessary, and it's important in order to promote the technology forward and to expand the markets at the current rate and even faster as the applications open up. Partnerships are driving strong advancement in both business and technology as the producers of technology align themselves with the users to create best-in-class solutions. Large-scale grid implementations for energy storage in China, such as the one shown in this slide, represent a very important area for growth in the future. These installations are big and will push the technology to its limit, but I would say the ultracapacitors are up to the challenge. So in summary, ultracapacitors as a power delivery technology rely on change to drive its future. From the fact that ultracapacitor value proposition is rooted in its ability to respond to system change requirements Through the ways the ultracapacitor can change society, they are intimately tied to changes required for our safe and prosperous future. China is a country well positioned at the front of this change in the world, and as such has the opportunity to make decisions and implement programs which accelerate those changes. This is important because we need them now, not 10 years from now. And Maxwell is enthusiastic about working with Chinese companies, institutions, and the government now and in the future to meet the requirements of products and technology necessary to make those changes. With appropriate focus, collaboration, and support of one another, we can make continuous progress and accelerate the rate of that progress in pursuit of a cleaner and more sustainable future. Thank you very much.